Ray Optics and Optical Instruments. Part 4. When a ray of light passes through a triangular glass prism, it bends twice. The amount of bending depends on the refractive index and angle of prism. So when white light passes through a prism, it splits into 7 colors. This happens because each color has a different wavelength and therefore bends by a different amount. Violet bends most, which has the smallest wavelength, highest refractive index. Red bends least, which has the longest wavelength, lowest refractive index. This spreading of light into its constituent colors is called dispersion. Prism combinations are commonly used in optical instruments for purpose such as inversion of an image in prism binoculars. When the light beam enters the prism, from air into glass, it bends towards the normal because glass is optically denser than air. This bending is called refraction at the first surface. The light travels obliquely inside the prism. Because of the triangular shape of the prism, the second surface is not parallel to the first one, so the light will again bend when it leaves. When the light beam comes out of the prism, from glass to air, it bends away from the normal because it is now moving into a rarer medium. This is refraction at the second surface. The emerging ray is not parallel to the incident ray, it has changed its direction. The angle between the incident ray and the emergent ray is called the angle of deviation. It is denoted by the symbol theta here. Also, angle of incidence is equal to the angle of emergence. Optical instruments. Microscopes and astronomical telescopes are optical instruments. They work using lenses and mirrors to form images. Microscope is used to see very small nearby objects like cells, insects, etc. Simple microscope use a single convex lens to see small objects enlarge. A compound microscope uses 2 convex lenses to achieve very high magnification for viewing tiny objects like cells and bacteria. The magnifying power of a simple microscope is given by m equals 1 plus d by f, where d is the least distance of distinct vision, about 25 centimeters, and f is the focal length of the lens. The magnifying power of a compound microscope is the product of the magnifying powers of the objective and eyepiece lenses, that is, m equals mo times me. Astronomical telescopes. Astronomical telescopes are used to see very far objects like stars and planets. There are 2 main types of astronomical telescopes. Refracting telescope uses lenses. Reflecting telescope uses mirrors. Image formed or inverted and magnified. The magnifying power of a refracting telescope is given by m equals fo by fe, where fo is the focal length of the objective lens and fe is the focal length of the eyepiece lens. Video by Anand Mohandas.